Good morning, class. We are looking at College Algebra Practice 2, Module 2, covering chapters 3 and 4. Chapter 3, Functions. Chapter 4, Linear Functions. And now here's Chapter 3, Functions. Dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. So, along the x-axis, along the y-axis, what do we cover here? Let's find out. Relation. A set of ordered pairs. Domain. The set of all input values, x values, independent variable for a relation. It doesn't have to be x, the independent variable. Which means if you happen to have a graph, whatever it covers along the x-axis is the domain. Range. The set of all output values, y values, dependent variable for a relation. Which means if you have a graph, anything that it covers along the y-axis is considered the range. Okay, since it stops here and it goes indefinitely down here, from negative infinity to this. Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range. To check it for a graph, we use VLT, vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph does not represent a function. If not, then the graph represents a function. So if you can come up with a vertical line that crosses the graph more than once, it is no longer a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. So we use horizontal line test for that. If a horizontal line can be drawn, horizontal line like so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. In other words, a graph represents a function if the x coordinate doesn't repeat, and it represents a one-to-one function if the y coordinate cannot repeat. So, for example, right here, you can see that it fails the horizontal line test. DQ, short for the difference quotient, f of x plus h minus f of x over h, and h can't be 0. In short, if you have 2 points, you want to calculate the slope. That is the DQ, the difference quotient. All right. Find the domain of each function using interval notation. F of x is x minus 5 over 2x minus 1. Whenever you have a rational function, you set the denominator equal to 0 and you exclude that. So 2x minus 1 equal to 0 gives us x equals 1/2. And x can't be 1/2. Now, x can't be 1/2. You can write this as the domain, but in an interval notation goes from negative infinity to 1/2 union 1/2 to infinity. Notice parentheses mean we are excluding the endpoints, namely 1/2 here. F of x is square root of 5x plus 4. Anytime you have a root function where the index is even, remember, When we don't write the index, that means is square root. That means the index is 2. Then what's underneath must be greater than or equal to 0. 5x plus 4 must be greater than or equal to 0. Move it to the other side. Divide by 5. Again, this is the inequality format, and this is the interval notation. From -4 to infinity, notice bracket means the endpoint is included because we have the equality. F of x equals x squared. The domain is all real numbers. You can write all real numbers or negative to positive infinity. Why is that? It is a polynomial with a degree 2, known as a quadratic function. All polynomials, the domain is all real numbers. We are going to continue with more functions. For example, cube root of x. The domain is all real numbers. Why is that? Because the index is odd. When the index is odd, there is no restriction. To give you an idea about that, remember square root of 4 is 2. Square root of -4 is not a real number or 2i. However, cube root of 8 is 2. Cube root of -8 is also a real number, -2. That's the difference. F of x equals x plus 3 over x squared minus 1. Again, we are dealing with a rational function. We set the denominator equal to 0, exclude those values, x squared minus 1 equal to 0. That means x squared is 1, x is plus minus 1, and we are going to exclude that. So this is one way to write the domain. The proper way using interval notation would be -infinity to -1. You go with the smaller number first. Union -1 to 1, union 1 to infinity. Notice we have parentheses around all those, okay? Endpoints. F of x is 2/3 x plus 7. The domain is all real numbers because it's a polynomial of degree 1 or simply a linear function. So it's pretty straightforward, everybody. We're going to move on. All right. Determine if the graph represents a function, a one-to-one function, and find the domain and range of each using interval notation. This one is a function and it is a one-to-one function. Y is a function. It passes the VLT, vertical line test. Y is the one-to-one function. It passes the HLT, so it's both function and a one-to-one. What about the domain? The domain starts, just lay this along the x-axis, starts from 2. And there's a hole here, ends with 8, solid point. And that takes us from 2 to 8. 2 is not included, 8 is included. The range goes from here to here, to here, from 6 to 8. 6 is included, 8 is not. Part B. Is this a function? Yes, it passes the VLT, vertical line test. Is this a one-to-one function? Just look at any horizontal line. For example, this one, you can see these two are having the same y coordinate. So it's a function, yes, one-to-one, no. What about the domain? Well, if you look at this one, so we want along the x-axis. From here, it covers this point. And goes all the way to this point, and this is solid point, this is a hole. So from -3 to 2, -3 is included, 2 is not. So -3 included, bracket, 2 is not. But what about the range? Look at the range. It covers from here here along the y-axis, all the way to up here. And they both are included, so from -5 to 4. Both of them take brackets. Last one, is this a function? No. Is this a one-to-one function? No. It fails the vertical line test. Look at this vertical line, these 2 points, for example. Look at this horizontal line, look at this. It is neither nor. That means it's not a function, it's not a one-to-one function. What about the domain? Look, it covers from here to here. So here, down here, all the way to 0. So down here is -4 to 0. Then along the y-axis, the bottom covers 0 and the top covers 4, so 0 to 4. Very straightforward. Given the function f of x equals to x plus 1, find and simplify f of x plus h minus f of x over h. And I want to discuss that. Rates of change. Look at this curve. You pick 2 points, you connect them. This blue line is called the secant line. Rates of change, the difference quotient delta y, where delta x equals f of x up to minus f of x sub 1 over x up to minus x sub 1 is called the average rate of change of y. or f of x with respect to x over the interval of x of 1 to x of 2, and can be interpreted as the slope of the secant line PQ. So this is the secant. There are different ways of writing that. M delta y over delta x, rise over run. If you look at these two pairs with the coordinates f of x of 2 minus f of x of 1 over x of 2 minus x of 1. If you call this point B and point A, so f of B minus f of A over B minus A. Or if this is A and this is X, would be f of x minus f of A over x minus A. If you call this distance H, f of A plus H minus f of A plus H minus f of A over A plus H minus A, which becomes H. And normally this is used as what we call the difference quotient. So one f of x of x plus h minus f of x over h. So obviously f of x is itself, h is fine. You are really concerned with this, becomes 2 times x plus h plus 1. That's it. And we are going to simplify this, everybody. So 2x plus 2h plus 1 minus 2x minus 1. These two cancel each other. These two cancel each other. And you get 2. Given the function f of x equals 2x squared plus 1 and g of x equals 3x minus 5, find f of g of 2. Well, operation of functions, f plus minus g of x means f of x plus minus g of x. That means the sum and the difference functions. Fg, that means f of x times g of x. F over g, that means f over g of x, where g, of course, can't be 0. Composite function f of g is f of g of x, g of f, g of f is g of f of x, and domain of f of g, and this would be range of f of g if we start with the g function. This is the domain of f, range of f. This is domain of g, range of g, and f of g is such that g of 2, the range of the g, becomes the domain of f of g. So, what do we mean by that? Let's find out. You want f of g of 2? First, you have to find g of 2. That's the concept that is explained here. What is f of g of 2? Ignore that. Just find g of 2. 3 times 2 minus 5, 6 minus 5 is 1. So what is f of g of 2? F of 1. So you want f of 1. 1 goes into the f function, becomes 2 times 1 squared plus 1. This is 1 times 2 is 2, plus 2 becomes 3. F of g of x by definition means f of g of x, which means the f function replace the x with 3x minus 5. So we need to raise this to power, reminding everyone that a plus minus b squared is a squared plus minus 2ab plus b squared. So we want the top one, a plus b squared. So you square this one, you get 9x squared. You multiply these two and then times 2. 2 times 3, 6x times 5, 30x, and you use a negative sign. So minus 30x, and then this is 25. We are going to distribute the 2. So 2 times 9x squared, 18x squared. 2 times negative 30x, minus 60x. 2 times 25 gives you 50. You add 1, you get 50. That's how you add them up. We're going to continue with the same question. We want to find GOF of x, which means right here you are going to replace the x with f of x, which is 2x squared plus 1. This gives us 6x squared plus 3. And these two numbers, positive and negative, positive 3 and negative 5, they add up to negative 2. G of x, that means g of x, that means replace the x with 3x minus 5 in the g function. So obviously distribute, you get 9x minus 15, and this doesn't change. These two add up to negative 20. 9x minus 20 is the final answer. We want FOF of negative 2. So what does that mean? Again, we are continuing with the same question class. It means we want f of -2. So that means find f of -2 first. Find f of -2 first. That means put -2 in here. So we get 4 here, 2 times that is 8, plus 1 on 9. That means we want f of 9. So plug in 9 into this function. 2 times 9 squared plus 1. 9 squared is 81. 2 times that is 162, plus 1 is 163. Determine if the functions f of x and g of x are odd or even. So let's look at the definition of an even and odd. Even function, f of minus x equals f of x. So it means if you replace the x with minus x, nothing happens. You get the same function. It makes it symmetric with WRT, with respect to the y-axis. Whereas odd function f of minus x makes it minus f of x. It makes it symmetric with respect to the origin. So what should we do? Evaluate each one as minus x. So f of minus x. So into this function, replace the x with minus x. So minus x to second power is itself, x squared. Two times that is 2x squared plus 1. It's identical to f of x. It makes it an even function. We're going to work on g of x. We're going to do the same thing. We are going to replace the x with negative x. And we get minus 3x minus 5. As you can see, this is not equal to g of x. So it's not even. This is not equal to minus g of x. It's not odd either. So g of x is neither odd nor even. Find the average rate of change of each function on the given interval where f of x is 3x from -1 to 1. And simply put, it means rise over run, everybody. We've already discussed that. The average rate of change of y with respect to x is f of b minus f of a over b minus a. So f of a 1 minus f of -1 over 1 minus -1. That's according to the definition, rise over run. The average rate of change of y with respect to x. So f of 1 would be 3 times 1 minus 3 times -1. The denominator obviously is 1 plus 1 or 2. 1 plus 1 is 2. And this is 3. That should be 3 times, there is a 1 here, which makes it 3 plus 3. 6 halves or 3. So it's pretty straightforward, everybody. A similar question, f of x is 2x minus 9, and the interval of a 4 to a. So f of b minus f of a, that means in this case, or f of x of 2 minus f of x of 1 over x of 2 minus x of 1. So f of a minus f of 4 over a minus. So f of a simply 2x minus 9. F of 4, 2 times 4 minus 9. The bottom is just a minus 4. So this is f of a to a minus 9, and this is f of 4, 2 times 4 minus 9. So let's see what we get here. This is 8 minus 9 is negative 1. And this makes it plus 1. 2a minus 9 plus 1 makes it 2a minus 8. Obviously, we can factor the 2 from the numerator and then drop the common factor of a minus 4. The answer is 2. F of x is 3x plus 4, and the interval of 2 to 2 plus h. That means, again, f of b minus f of a over b minus a. So f of 2 plus h minus f of 2 over 2 plus h minus 2. Or you can think of this concept, f of a plus h minus f of a. In this case, a is 2. Obviously, you can see the denominator becomes h. These two cancel each other. Let's look at the numerator. F of 2 plus h, that means 3 times 2 plus h, plus 4, minus f of 2, that means 3 times 2 plus 4. So let's write that. So what is left is just simplification of the numerator. Let's do that, everybody. So 3 times 2 is 6, plus 3h, plus 4. And I hope you see that this is 10, right? 6 and 4, 10. Minus 10. So what happens is 6 and 4 and minus 10 cancel. The numerator is only 3h over h. The final answer is 3. Pretty simple, everybody. Graphing techniques. We want to discuss the graphing techniques, everybody. Vertical and horizontal shifts. First, let's look at this graph. What is the concept here? You have this one. Which says this is y equals f of x. And we are assuming c is some number, some constant, which is positive. So what is f of x plus c is the same function shifted up by c units. What is f of x minus c? The same function coming down by c units. What is f of x minus c? The same function shifts right by c units. What is f of x plus c? Shifts left by c units. That's the idea, everybody. Now let's look at the same function y equals f of x. And now we are going again to look at c, but this time c is the number which is larger than 1. That's the assumption. So we look at compression, stretches, and reflections. So if we multiply the function by c, and remember c, we are assuming it's larger than 1, it stretches by that factor. The y coordinates become larger by that factor. And 1 over c, it becomes smaller by that factor, meaning the same x coordinate, the y coordinate is getting larger by a factor of c here, smaller by a factor of 1 over c. Now, if we put negative in front of f of x, it flips over with respect to the x-axis because y becomes negative in essence. Whereas if you put it in front of x, its reflection along the y-axis becomes x becomes negative, assuming x is right on the right and left on the left, which is always the case. So that's how those reflections and stretches and shrinkage works. That's the synopsis of that. The following function was graphed by applying transformation to a toolkit. And we say toolkit, we mean elementary functions, essential functions. Write the equation of a function that matches the graph. So what are the toolkits? Some of the functions we should know are as follows. For example, the constant function y or f of x equals b is a horizontal line with the y coordinate of 0. We should know the graph. The identity function f of x equals x or y equals x is a line through the origin. Square function or the quadratic function f of x equals x squared, it's a parabola opens up. Cube function f of x equals x cubed, looking like that. The square root function f of x equals square root of x, looking like this. And finally, the cube root looking like that. Now, why is this important? So right away from here, we notice the domain is all real numbers. The range is only b. Over here, this one, and this one, I hope you realize that domain and range for all three cases are real numbers. Domain and range, all real numbers. For the constant function, the cube function, and the cube root function. For y equals x squared, domain is all real numbers, but the range is from 0 to infinity. And for square root of x, domain and range from 0 to infinity, for the x, which makes it the domain, 0 to infinity for the range. So when you know essential functions, you know all the important aspects of them. And that is extremely important, everybody. So there's another function that we should know. It's an absolute value function, which looks like a V shape with the vertex located at 0, 0. Y is absolute value of x. The vertex is located at 0, 0. So this is 0, 0. But this one, where is the vertex located at? Number 3 here, number 2, clearly this is located at 3, negative 2. The new vertex is located at 3, negative 2. So what do we do? Let's write the general format. Y is A. A means some number which we don't know. This is the absolute value, x minus h plus k. So if that is the case, 3 minus 2 means x minus 3 plus negative 2. So for example, if it was minus 3, this becomes plus 3. So x minus 3, and this one unchanged. Now what do? You pick up a point that is easily recognizable. What about the intersects? This is located at 1, 0. This is located at 0, 1. If you plug in any of those pairs, you can figure the missing A, everybody, and let's do that. So those are the two easy points. Let's say we are going to use this one. So if y is 0, x is 1. So obviously this is negative 2. But absolute value of negative 2 is positive 2. So we get 2a minus 2, and clearly a becomes 1. So we replace the a with 1, and this is the final answer, everybody. Now, what do you do with the final answer? You must check, and I'm going to leave it for you to check. The way you check, you pick up a few pairs to make sure it works. For example, you make sure this one works, which obviously if you plug in 0, you get absolute value of negative 3, which is positive 3 minus 2 is 1. And then you pick other points. Maybe this point. For example, okay, or this point. So pick up easy points, at least 2 more to be on the safe side. You check, and it shows we haven't made a mistake. Okay. This is very important, everybody. The following function was graphed by applying transformation to a toolkit function, and such as the functions that have been mentioned. Okay, f of x equals x squared and so on, etc. Write the equation of a function that matches each graph. Remember, if we know the basic graphs, we know it looks similar to this function. We should recognize that as f of x or y equals square root of x. And working on that, some sort of a transformation should result in this. We start with writing when y equals square root of x, we know the intercept takes place at 0, 0, and that location 0, 0 has been shifted to this location, which is -3, -1. So let's write it in this format. It makes it easy to see what's going on. Y equals a squared of x plus k. The x has been shifted 3 units to the left, so x plus 3. And k, it's been shifted down by 1 minus 1. Now, all you have to do, pick any point that it's easy to see. For example, clearly this point has coordinates -2, 0. So that would be an easy point to use. Just plug in, observe. So a times square root of x is -2 and y is 0. So this is everybody 1 comes out as 1. And so a minus 1 is 0, a is 1. So everybody can see that we can easily come up with the answer by picking up an easy point. And it is highly recommended that you check with other points class. For example, maybe this one. Just make sure the points that you pick are easy and you definitely are reading it right. The following function was graphed by applying transformation to toolkit function. Again, it's mentioning various functions. F of x equals x squared, square root of x, and so forth. Write the equation of the function that matches each graph. So this is the graph that we are interested in. So let's see what we need to do. We clearly recognize this as a parabola that opens down. So the regular one is f of x over y equals x squared. Opens up with the vertex at 0, 0. And I hope you remember the general format. First and foremost, the vertex which was at 0, 0 has shifted to this point with coordinates -1, 2. And we have, I hope everybody remembers this, y equals a times x minus h quantity squared plus k. So whenever you have the vertex, it makes it pretty easy to find the equation. So the vertex is -1, 2. So this would be y equals a times x minus -1, which makes it plus 1 quantity squared plus k or plus h or plus 2. So all we have to do, pick up a point that is easily read. You can read this as 0, 1. And we are going to replace the x with 0, y with 1. That will help us find the missing a. So this is 1. This is 1 squared is 1 times is a plus 2. If 1 is a plus 2, a becomes negative. So replace the a with -1. We get y equals minus x plus 1 quantity squared plus 2. And as you recall, when a parabola opens up, a is positive, opens down, a is negative. And again, you want to pick an easy point and check. Just find a couple of easy points. Obviously, this would be an easy point. -2, 1. And for example, let's actually pinpoint that. This one everybody can see. It's an easy point to see. So if you plug in -2, you get -1 squared. +1 with negative becomes -1, and 2 is 1. So it works. Pick up a couple of pairs, easy points, and check. That's really the bottom line, everybody. Find the equation of a function that is finally graphed after the following transformation are applied to y equals x squared. Shift right 3 units. F of x is x minus 3 quantities. Now it's important to know. Now this one, so we are done with this. This is gone. Now we are, and you have to look at the question, the way they ask. Does this apply to the original one or the next one? The way it's asked, now it applies to this one. Reflect about the x-axis, put a negative sign in front of the y coordinate in essence. Remember, to negate f of x, you put a negative sign. Now, this is gone, this is gone, this is the one that is left, and this applies to this. Shift down 2 units. That means this function, bring it down by 2 units. So add a -2. So the final answer, f of x is minus, the parenthesis x minus 3 squared minus 2. This is the final answer, everybody.